The concrete batching plant consists of aggregate powder and liquid weighing systems, conveyor belt, as well as mixing, control, storage, and other related systems. Component structure and features. Aggregate batching system. Weighing may be done in accumulated or separate modes, according to the operational form. The separate weighing occurs when each aggregate has a batcher to weigh separately. The accumulative weighing uses a belt scale to weigh in shifts. The weighing range is checked and adjusted according to the capacity of the allocated mixer, with measuring accuracy allowing for a plus or minus 2% error. Generally, the aggregate is designed with a total of 4 storage deposits, 2 for stone, 1 for sand, and 1 for sand or fine stone. The stone deposits do not have vibrating arch to break the rocks. The bottom of each storage deposit has a screw to adjust the opening degree of the aggregate door as required, controlling the flow of the materials. On the opposite side of the storage room, there is a device to prevent the material from getting stuck. The storage capacities of a single aggregate are 13, 20, 25, 30, and 45 cubic meters, which can be changed according to the customer's requirements. Conveyor belt. The aggregate is conveyed from the batcher to the main building using a belt feeding system. There are 3 choices of belts available: groove belt, herringbone belt, and flat belt. The groove belt feeding conveyor is recommended if the installation space is small. If the space available is large, the flat belt feeding conveyor is recommended. The herringbone belt is the best choice for medium-sized areas. The groove belt feeding system features small occupied space and fast fabrication and installation. However, this belt tends to get more sand stuck on it, and it's more difficult to clean up. The flat belt feeding presents requirement of ample space and longer period of fabrication and installation. This belt has an automatic cleaning device. Generally, the flat belt is appropriated for fixed mixing stations and large ready-mixed stations. The flat belt conveyor is commonly designed with double aisles for maintenance. Both sides are equipped with emergency pull switch to stop the belt. The middle tensioning device functions with an automatic gravity-type sensor. The tightness of the belt is adjusted by the feeding increasing and decreasing, and the band pulley lubricity is led to both sides of the aisle via the filler tube and lubricating nipple to add grease lubricant. The position of the head band pulley is equipped with an automatic spray cleaning device for washing the sticky sand on the belt surface to the waste chute under the belt rack. The width of the belt has 2 specs of 800 mm and 1000 mm. The belt width and speed are selected by the different models. Weighing system. The weighing of powder generally has 2 kinds of cement weighing systems and fly ash weighing system. According to the actual needs, it can use cement and fly ash cumulative weighing or individual weighing. The weighing range is checked and ratified by the mixer capacity. The weighing accuracy is normally of plus or minus 1% error. The water and additive weighing systems generally use a pull-time weighing sensor. The outlet is with a pneumatic valve assembly, using soft connection with the mixer inlet to ensure the weighing accuracy. The weighing range is checked and ratified by the mixer capacity. The weighing accuracy is normally of plus or minus 1% error. The feeding process is normally unloading the additive and water to the mixer together, and putting the additive into the water, then unloading to the mixer. If the mix main building selects equipped with an outsourcing closure, the internal will be with a bag-type dust collection system, together with a wind guiding device. The dust collection system can effectively absorb most of the dust which is generated when putting the aggregate and powder into the mixer and return to the mixer, enabling to reduce dust pollution of the environment. The wind guiding device is mainly used to guide the feeding airflow to outside the main building in a short time and prevent the instantaneous overpressure impacting the accuracy of the weighing system. It all uses compulsory twin horizontal shafts. The shaft tip is with 5-sealed structure. The shaft tips supporting and the seals separate each other. The customer only needs to add the grease lubricant to the oil barrel, as required in time. Arc liner and mixing blade use high chromium and high manganese alloy cast iron, which is wear resistant. Normally, the life can reach 3 to 4 million cans of times. Observe and check the door safety device to ensure the safety of check and maintenance. Discharge pipe uses multiple sprays to ensure the mixer shaft and arm without cement blocks. Powder storage and conveying system. The powder storage can normally has specs of 50 tons, 100 tons, 150 tons, 200 tons, 300 tons, and others. The accessory of the powder can includes top dust collector, level indicator, arch breaker, top pressure safety valve. The conveying of the powder is using screw conveyor, the specs of 219, 273, 323 diameter, and the conveying efficiency is 20 to 100 tons per hour. The efficiency is related to the conveying angle. Selection of the screw conveyor. At station HZS50, using diameter 219 to convey the powder. At station HZS75 and HZS100, using diameter 273 to convey the cement and using diameter 219 to convey other powder. At station HZS150 and HZS200, using diameter 323 to convey the cement and using diameters 219 or 273 to convey other powder. Control and management system. The system is with PLC plus IPC model, in which PLC buttons and intermediate relay use Siemens. The other major components use Schneider and LS.